Cheers everyone, Cloudfather here. Today we're going to go back and do some more testing on this scrap wood material. This is a hardwood. Yesterday we finally started getting down fairly close to what we needed for basically cutting inserts. Today we're going to reduce the DPI down to 50, see what that looks like. We're going to center our testing around 10,035 Z15. That seems to be the best compromise from all the testing we've done so far. We're going to make another pass at 150, which will be kind of in the middle. And what we're looking at for these passes is to see how cleanly we can get a recess cut into this hardwood. Okay, we're just about ready here. We've gone through and set up our parameters. The power is set at 35, speed is 10,000. We're in fill mode. We're using bidirectional fill crosshatch. Overscan is 0.25%, excuse me, 2.5%. The lines per inch vary from 50 to 150 to 250. Again, we're trying to see a range of what it does to this material in terms of how level we can make the milling that we're doing into the surface of this hardwood. So let's go ahead and start that. Okay, we're starting our first one. This is at 50 DPI. We're getting actually a fairly clean pass on that. This is at 35. You can see that we're not getting a lot of smoke. We are getting a tiny bit of flame, but well within reason. This, of course, runs quickly because we're running a 10K. So it'll be very interesting to see what this looks like. Crosshatch is starting to look good. We're now in the vertical side. And we're starting to see the grain. So it'll be interesting to see the difference in leveling between each of these passes. Okay, we've got the second cut going. This is at 150 DPI. And now we'll see what the difference is between 50 and 150 DPI. Okay, let's notice the difference now. We're at 150 DPI and we're doing our vertical pass, and we're getting quite a bit more smoke and the occasional burst of vapors igniting. Again, we're right at the edge case for non-modified lasers to work with this. We're now on our last test. We're looking at 250 DPI. You notice you have a little more flame, but that's because we've increased our number of lines. And it'll be interesting again to see where this comes out relative to each other from a DPI perspective. Again, what we're testing for is to sit down and look at what gives us the best average surface. The other thing to think about is at 10,035, we're centered on the best of the previous test cases. So what we're doing is trying to figure out where do we get flames starting, where do we get burn marks starting. Where this is running right now in the higher DPI, the 250, is we are starting to see surface flame, but no burning wood. This is right in the edge of where your flame sensor is probably going to start tripping. So we'll see what kind of results we get with this. Again, you're right on the border of where it's going to be a problem for an unmodified laser. Okay, we're starting the vertical pass on the last test. Again, we've got a fair amount of smoke. You're starting to see some flashing where the vapors are igniting. Again, this is where your flame sensor is going to go off. So what we're learning here is, in fact, the higher the DPI, the more smoke and debris you get. And in this particular one, if we were going to do it again, we probably would run it at 30 versus 35, maybe even 27, to stop the burn marks that occur from the vapors evaporating and then burning. So again, this is one that's right on the edge. Now, one of the other things that you can think about is if you're recovering wood, this is actually a good way to take a painted piece of wood and resurface it. So not only can we cut pockets, we can resurface. And if you're going to do 3D work, this really helps you understand how the grain is and how it's going to react to the laser. And in fact, to create a clean layer to start doing three-dimensional on, you might want to run a pass like this at 24,000, and that would burn off all the paint materials and will basically clean the top of the material for use for doing deep 3D. So there's a lot of things we're learning as we're going through this test. Now the next thing we're going to do is we're going to change the parameters again. And what we're going to do is take exactly the same 3 test runs. We're going to move them up above this row, and then we're going to run 4 passes. And we're going to measure between the single pass and the 4 pass and the changes in DPI, what the difference is in terms of how deep the pocket is. So again, we're gaining more information and more dimensions of measurement and things that we can change when we want to do an inlay. We're now setting up for the 4 pass. And so we're at 10,035, fill mode, bidirectional, crosshatch, overscan 2.5, line interview interval 0.580, lines per inch 50, number of passes 4, and we're also now using the Z step per pass at 0.5 positive, which means it's going from a focus of 15 to a focus of 14, so it's getting closer to the work surface. We're now going to modify all the rest of them here so they're consistent. So that takes care of the black one. So we're going to increase the passes. This one's 150 lines per inch. We're going to turn the Z steps on at 0.5. Again, everything else is the same. Same thing here, increase the pass count. Set up a positive Z increment, which means we're closer. Every time the pass goes, we go ½ mil closer. So we're moving the focal point down closer to the bed. So now everything's ready to run. We've done our framing pass. We're going to go ahead and start that. Okay, so for the first box, after 4 passes, it's a little darker. As it gets down to the 4th layer, you're starting to get more burn, getting a little more smoke. It's still within reason for a standard laser. When this pass is done, we'll start comparing the depth between the one below it. Both are at 50 DPI. So we can see how deep each pass is doing. We're now also on the 2nd pass, and we're just getting started with that. Okay, so we're done on the 4 pass, and we clearly have gotten a much deeper insert than we had with the single passes. Right now we're using right angle cross The next passage, we're going to run exactly the same test, but we're going to tilt everything 45 degrees. And we'll be looking at, do we get more depth? Do we get a flatter span across the insert? So here's our setup. We're 10,035 fill, 2.5% overscan, 50/80 for the interval. Lines per inch is 50, 150, and 250 between the three different test squares. But what we've changed is the scan angle. It's now 45 degrees. The crosshatch will look like this. And that's going to be very interesting because before we were doing basically with the grain and cross the grain. Now everything is cross the grain regardless of orientation. We're also doing, again, 0.5 millimeters per pass. And we've already set everything, so we're just going to go ahead and run that. So we'll check with that when that's finished. Now, if we watch this, before we were basically going with the grain and cross the grain. Now we're going 100% cross grain because we're running in 45-degree scan mode. So again, it'll be very interesting to see what this does. The other thing is, notice the color differences between 4 passes and 1 pass. It gives us all kinds of interesting information about if we want to just clean a piece of wood and take the surface off, what kind of power levels and DPI will we use in order to achieve that result. So one thing we're noticing with the cross is we get a little more bursty flames than we did with the zero angle. So that's something that is moving our edge case away from a stock laser. It depends on how sensitive your flame detector is. It'll be interesting to take a close look outside the enclosure as we start comparing the surface fitness, looking for how smooth it is across and how consistently deep it is. So the next thing we'll look at is when we look at the final pass. Okay, mates, we're now set up. What we've done is we are now setting up the laser to run in 35 watt mode. So we're switching the switch, and now it'll be doing half the power and half the beam width. The test cases that we have set up, and there are 9 of them, because we know this isn't going to flame nearly as much as 75 watt mode, I can let this run safely without having to watch it all day. The total runtime will be about 3.5 hours. So as we've been going through the process of basically doing a beta test on this material, we're going through and we've taken corner cases. We keep moving to getting closer and closer to the desired outcome of a clean pocket. Now we're trying half beam width size to see, does that give us a more precision approach? Do we get less variation across the square that we're trying to mill out of the material, which I suspect is probably oak? So we're working at 10,000, we're working at 70% power in 35 watt mode. We're at the default autofocus, which on the screen will show Z14, but it's always off because it starts counting at 0 instead of 1. So it's actually 15, which is what's reflected on the Lightburn design page here. On the bottom, we're going to do just a bidirectional pass, so it's just going to go this way. We're going to do 4 passes. The next one is with a 0 degree cross patch, which means it's going to go horizontal, then it's going to go vertical. which is effectively 2 passes times 4. So we'll see what the result there is. The top one is 4 passes at a 45-degree cross, which means you're cutting the grain, cross grain both ways, basically getting it diagonally. And then we have our columns of 50 DPI, 150 DPI, 250 DPI. That will give us a pretty good range to figure out for this material and this type of laser at half beam size at the same effective power level, what we can do with this material. So that's what we're going to try next. So we're going to go ahead and start that, and then we'll check back in about 3 hours to see how long it took. Yeah, it thinks 3 hours and 25 minutes. Unfortunately, in release candidate 4, that's probably more like about 4.5 hours. So it's now 1:03, so we'll go take the dog for a walk and do some running around, and we'll check back in about 4.5 hours. Again, because we know what the wood's characteristic is now, we know how much flare up we're going to get, and in this very high extraction volume chamber, we don't have a fire issue. But if you're doing this at home, we're right at the very edge of where your flame detector is going to be constantly popping off. So if you're doing this at home, drop the power down to start at 50% instead of 70% if you're using a 70-watt laser. That way you won't get the flare-ups. The other reason for the flare-ups is, of course, we're burning off shellac covered with 3 coats of Rust-Oleum paint. So if you're just using a clean wood that has no varnish, just normal tree sap, you're not going to see as much flare up. So again, we've already proven that we can run these 9 different tests in series without observation. Again, I have fire detection in the chamber. I can also watch it remotely on my cell phone while I'm out walking the dog. So I don't expect we'll have any problems with it, but you never know. At any rate, I do have the ability to remotely send the argon in and quench any fires. But at the level that we're burning, when we did the first test, one of the first things we did is we actually figured out when the board would actually catch fire. So we did 3 different tests right at the very beginning, and you can see where we clearly had the burn. It was burning by itself even with the fans on. And then the next one, it would catch on fire, would flare up a lot, where it would drive the smoke detector crazy or the flame detector, but it wouldn't stay on fire. So that was an important threshold to know. Then the third one, we tuned it quite a bit, where we got a fair amount of flare-ups, but no fires at all, nothing continuously burning. And then that's when we set the rest of the tests up from there. We went and did a pass with bidirectional at 20, 30, and 40. 40 being the edge in bidirectional mode, where you started to get to the point where you're going to get enough flare up where you might start a fire. And then we backed things down in the later passes. We threw out the 20, we threw out the 30, and we went between 30 and 45 in 70-watt mode. So now the mode we're doing now is we're in 35-watt mode, half the beam size. We have adjusted for the same optical output power. So we're basically getting 35 watts or 35% of 70 watts going directly to the surface, but we're running 70% in 35-watt mode versus 35 in 70% mode. So we get the same effective power. So time to go walk the dog. We'll check back in a few hours. Okay, we're just about done. We have done 9 squares, each with different parameters. The parameters are basically like this. I did them all with different layers. And we went in the bottom row bidirectional. In the vertical columns, we're going 50, 150, and 250. And then the middle one is 0 degree cross, and the top one is 45 degree cross. So we're going to let this finish, and we're going to go back in the lab, and we're going to talk through the results and different applications for this type of information. So on the 70 watt side, 70 watt side at 35%, we vertically did 50, 150, 250, and horizontally we went bidirectional, cross with 0, and then cross with 45. So on the 50s, you pretty much couldn't measure it. It was more, it was less than 0.2 mils. So it's basically just taking the paint off or the top layer. When we get to 150 DPI, now we start seeing some differences. So at 150 DPI in the BiDi, which is the bottom row here, we got between 0.21 and 0.59. When we went to 250, we got 0.6 to 0.82. And you can see that there's a reasonable depression there where we're trying to cut a hole to put a inlay in. When we go to the next row up, we're using cross at 0 degrees. So it basically goes this way, then it goes this way. And we're doing it 4 times, so it actually crosses 8 times. The BiDis are simply 4 times. We start seeing 163 to 0.193. So that's pretty reasonable if you're trying to put a 1.5 mil piece of basswood or acrylic plastic in. So the next one over is 250. Now this is 268 to 294. So we have almost 3 mils there. That's getting to be a very practical thing to do an inlay, particularly if you're doing a wood-on-wood inlay, because the advantage of doing the wood is you can sand it so it's all the same level. You just sand it once. Now we go up to the top row, and everything's still the same, except for we're now using a 45 degree cross. Now the 45 degree cross gave different results than the 0 cross. So we went from a 115 to 221, so we actually had more variation and more depth. And then when we went to 250, we went from 148 to 2.49. So it's really kind of interesting, and we got curved depth, which probably has something to do with the fibrous nature of the grain within this wood, which is probably, we think, oak of some kind. Now the difference here is we've actually used the same optical power, but we're in 35 watt mode instead of 70 mode. So we multiplied the power by 2, which gives us 70. So all these squares are 10,070. Z is still at 15. We have 50 DPI, the vertical column on the left. Center column is 150 DPI, and the right column is 250. So in BiDi, we basically, just see what looks like an old school TV, usual lines. When we do cross, we see basically a bunch of little squares. And when we do cross at 45, you see it rotated by 45 degrees. Again, these are just surface layer. They're below a mil, so not particularly useful unless you're just trying to clean something. We start seeing the most change when we start getting to the 150 and 250s. All of these are 4 passes, just like the previous ones we looked at. In the bottom one, the BiDi, of course, is going this way back and forth, and then it's going up and back and so on until it has 4 passes. So it's actually going over 8 times. And so we got 0.26 to 151, which is a fair amount of variance. And we got some interesting patterning. As we move over to the BiDi in the 250, the patterning went away, but we see a lot more depth. We're going from about 128 to 265. So these are actually quite deep. Again, what we're really looking at is the edges here, because that's what counts if we put something in here. The rest of this stuff we can fill with wood filler or just put glue in. You know, if you let it dry and level, and then you put another layer on and then put your material in for your inlay, then you got a smooth surface. Now we go to the 0 degree cross. And so it's going back and forth and up and down 4 times, so we're a total of 8. So it went from 1.81 to 276, and you notice the grains really stand out. The soft material is being ablated, the heavy fiber is what's left. We do have nice clean edges, so we put our piece in. We would probably put a 150 or 155, 1.55 mil piece in, and then if it's wood, we'd sand it so it's level with the surface. Now, one thing about this board, it's very curved, so that is skewing the results a little bit. Let's move to the cross 250 DPI with 0. This one was 316 to 417. This really cut into the wood. You notice it's quite deep in here. We see very clear structure of all the fibers in there. We've got good clean edges. And again, if we fill this with glue or a filler, we can get a nice even surface. And we can put probably a 2 to 2.5 mil thick piece of inlay in that. Now if we go up to the 45 degree passes, on the 45 degree passes you see the same pattern you see here in the cross with 0 degrees. In the 45 degrees you just see the pattern this way. When we go to the 150 DPI, it's interesting, it has really deep ridges. So we went from 129 to 174, and some of those might be as deep as 2 1/4, but it was difficult to get level across this to measure it. The best result with the cross at 45 was 226 to 381. That was fairly minimal variance. We can still see the structure of the fibers. This will be fairly easy to fill. We've got plenty of lip here, so we can put a 2.5 mil piece in there. So this is an example of milling with a laser. There's lots of other applications of this. We're going to talk a little bit about the results in a third video, which we're going to talk about the analysis.